The Challenger Deep is the deepest known point in the Earth's seabed hydrosphere, with a depth of 10,898 to 10,916 am by direct measurement from submersibles, and slightly more by sonar bathymetry. It is in the Pacific Ocean, at the southern end of the Mariana Trench near the Mariana Islands group. The Challenger Deep is a relatively small slot-shaped depression in the bottom of a considerably larger crescent-shaped oceanic trench, which itself is an unusually deep feature in the ocean floor. Its bottom is about 11 km long and 1.6 km wide, with gently sloping sides. The closest land to the Challenger Deep is Fais Island, 287 km southwest, and Guam, 304 km to the northeast. It is located in the ocean territory of the Federated States of Micronesia, 1 mi from its border with ocean territory associated with Guam. The depression is named after the British Royal Navy survey ship HMS Challenger, whose expedition of 1872–1876 made the first recordings of its depth. According to the August 2011 version of the GEBCO Gazetteer of Undersea Feature Names, the location and depth of the Challenger Deep are 11 degree 22.4 euro squared N 142 degree 35.5 euro squared E and 10,920 ama plus or minus 10 am. June 2009 sonar mapping of the Challenger Deep by the Simrad M120 aboard the RV Kilo Mona indicated a depth of 10,971 meters. The sonar system uses phase and amplitude bottom detection, with a precision of 0.2% to 0.5% of water depth. This is an error of about 22 to 55 am at this depth. Further soundings made by the U.S. Center for Coastal and Ocean Mapping in October 2010 are in agreement with this figure, preliminary placing the deepest part of the Challenger Deep at 10,994 am, with an estimated vertical uncertainty of A plus or minus 40 am. A 2014 study concludes that with the best of 2010 multibeam echo sounder technologies, a depth uncertainty of A plus or minus 25 am on 9 degrees of freedom and a positional uncertainty of A plus or minus 20 to 25 am remain, and the location of the deepest depth recorded in the 2010 mapping is 10,984 am at 11.329903 a degree N 142.199305 a degree A / 11.329903. 142.199305. Only 4 descents have ever been achieved. The first descent by any vehicle was by the manned bathyscaphe Trieste in 1960. This was followed by the unmanned ROVs Keika in 1995 and Nereus in 2009. In March 2012 a manned solo descent was made by the deep submergence vehicle Deep Sea Challenger. These expeditions measured very similar depths of 10,898 to 10,916 meters. History of depth mapping from the surface. Over the years the search for the point of maximum depth has involved many vessels. The HMS Challenger expedition first sounded the depths now known as the Challenger Deep. This first sounding was made on March 23, 1875 at Station 225. The reported depth was 4,475 fathoms at 11 degree 24 euro squared N 143 degree 16 euro squared E, based on 2 separate soundings. A 1912 book, The Depths of the Ocean by Sir John Murray, records the depth of the Challenger Deep as 31,614 ft, reporting the sounding taken by the converted Navy collier USS Nero in 1899. Murray was one of the expedition scientists. In 1951, about 75 years after its original discovery, the entire Mariana Trench was surveyed by a second Royal Navy vessel, captained by George Stephen Ritchie. This vessel was also named HMS Challenger, after the original expedition ship. This survey recorded the deepest part of the trench using echo sounding, a more precise and easier way to measure depth than the sounding equipment and drag lines used in the original expedition. A depth of 5,960 fathoms was measured at 11 degree 19 euro squared N 142 degree 15 euro squared E. The maximum survey depth of the Challenger Deep was reported in 1957 by the Soviet vessel Vityaz, recording a spot 11,034 meters A plus or minus 50 am deep at 11 A degree 20.9 a euro squared N 142 A degree 11.5 a euro squared E. It was dubbed the Mariana Hollow and is listed in many reference sources, including the Encyclopaedia Britannica, articles in National Geographic and on maps. The pressure at this depth is approximately 1,099 times that at the surface, or 111 MPa. In 1959 the U.S. Navy research vessel RV Stranger using bomb sounding surveyed a maximum depth of 10,915 ama plus or minus 10 am at 11 A degree 20.0 a euro squared N 142 A degree 11.8 a euro squared E. In 1962 the U.S. Navy research vessel RV Spencer F. Baird using a frequency-controlled depth recorder surveyed a maximum depth of 10,915 ama plus or minus 10 am at 11 A degree 20.0 a euro squared N 142 A degree 11.8 a euro squared E. In 1975 and 1980 the U.S. Navy research vessel RV Thomas Washington using a precision depth recorder with satellite positioning surveyed a maximum depth of 10,915 ama plus or minus 10 am at 11 A degree 20.0 a euro squared N 142 A degree 11.8 a euro squared E. In 1984, the survey vessel Teikuyo from the Hydrographic Department of Japan, used a narrow, multibeam echo sounder to take a measurement of 10,924 ama plus or minus 10 am at 11 A degree 22.4 a euro squared N 142 A degree 35.5 a euro squared E. In 1998 a regional bathymetric survey of the Challenger Deep was conducted by the deep-sea research vessel RV Kaeru, from the Japan Agency for Marine Earth Science and Technology, using a Seabeam 2112 multibeam echo sounder. The regional bathymetric map made from the data obtained in 1998 shows that the greatest depths in the eastern, central, and western depressions are 10,922 ama plus or minus 74 am, 10,898 ama plus or minus 62 am, and 10,908 ama plus or minus 36 am, respectively, making the Eastern Depression the deepest of the three. In 1999 and 2002 the RV Kaeru revisited the Challenger Deep. The cross-track survey in the 1999 RV Kaeru cruise shows that the greatest depths in the eastern, central, and western depressions are 10,920 ama plus or minus 10 am, 10,894 ama plus or minus 14 am, and 10,907 ama plus or minus 13 am, respectively, which supports the results of the 1998 survey. The detailed grid survey in 2002 showed that the deepest site is located in the eastern part of the Eastern Depression around 11 A degree 22.260 a euro squared N 142 A degree 35.589 a euro squared E, with a depth of 10,920 ama plus or minus 5 am, about 290 am southeast of the deepest site determined by the survey vessel Teikuyo in 1984 and about 240 am east of the deepest place determined by the 1998 RV Kaeru survey. On June 1, 2009 sonar mapping of the Challenger Deep by the Kongsberg Simrad M120 sonar multibeam bathymetry system for deep water mapping aboard the RV Kilo Mona indicated a depth of 10,971 am. The sonar system uses phase and amplitude bottom detection, which is capable of an accuracy of 0.2% to 0.5% of water depth across the entire swath. In 2014 the multibeam bathymetry data of this sonar mapping have yet to be publicly released, so the data are not available for comparisons with other soundings. On October 7, 2010 further sonar mapping of the Challenger Deep area was conducted by the U.S. Center for Coastal and Ocean Mapping Joint Hydrographic Center aboard the USNS Sumner. The results were reported in December 2011 at the annual American Geophysical Union Fall Meeting. Using a Kongsberg Maritime M122 multibeam echo sounder system coupled to positioning equipment that can determine latitude and longitude up to 50 cm accuracy, From thousands of individual soundings around the deepest part, the CCOMJHC team preliminary determined that the Challenger Deep has a maximum depth of 10,994 am at 11.326344 a degree N 142.187248 a degree A/11.326344. 142.187248, with an estimated vertical uncertainty of A plus or minus 40 am at 2 standard deviations confidence level. A secondary deep with a depth of 10,951 am was located at approximately 23.75 m to the east at 11.369639 a degree N 142.588582 a degree A/11.369639. 142.588582 in the Mariana Trench. In 2014 a study was conducted regarding the determination of the depth and location of the Challenger Deep based on data collected previous to and during the 2010 sonar mapping of the Mariana Trench with a Kongsberg Maritime M122 multibeam echo sounder system aboard the USNS Sumner. This study by James V. Gardner et al. Of the Center for Coastal and Ocean Mapping Joint Hydrographic Center, Chase Ocean Engineering Laboratory of the University of New Hampshire splits the measurement attempt history into three main groups: early single-beam echo sounders, early multibeam echo sounders, and modern multibeam echo sounders. Taking uncertainties in depth measurements and position estimation into account, the raw data of the 2010 bathymetry of the Challenger Deep vicinity consisting of 2,051,371 soundings from 8 survey lines was analyzed. The study concludes that with the best of 2010 multibeam echo sounder technologies after the analysis, a depth and certainty of A plus or minus 25 am on 9 degrees of freedom and a positional uncertainty of A plus or minus 20 to 25 am remain, and the location of the deepest depth recorded in the 2010 mapping is 10,984 am at 11.329903 a degree N 142.199305 a degree A/11.329903. 142.199305. The depth measurement uncertainty is a composite of measured uncertainties in the spatial variations in sound speed through the water volume, the ray tracing and bottom detection algorithms of the multibeam system, the accuracies and calibration of the motion sensor and navigation systems, estimates of spherical spreading, attenuation throughout the water volume, and so forth. The 2009 and 2010 maximal depths were not confirmed by the series of dives Nereus made to the bottom during an expedition in June 2009. The direct descent measurements by the 4 expeditions which have reported from the bottom, have fixed depths in a narrow range from 10,916 m to 10,911 m, to 10,902 m to 10,898 m. Although an attempt was made to correlate locations, it could not be absolutely certain that Nereus reached exactly the same points found to be maximally deep by the sonar echo sounders of previous mapping expeditions, even though one of these echo soundings was made by Nereus mothership. Descents, manned descents. Trieste. On January 23, 1960, the Swiss-designed bathyscaphe Trieste, originally built in Italy and acquired by the U.S. Navy, descended to the ocean floor in the trench manned by Jacques Piccard and USN Lieutenant Don Walsh. Their crew compartment was inside a spherical pressure vessel, which was a heavy-duty replacement built by Krupp Steel Works of Essen, Germany. Their descent took almost 5 hours and the two men spent barely 20 minutes on the ocean floor before undertaking the 3-hour and 15-minute ascent. Their early departure from the ocean floor was due to their concern over a crack in the outer window caused by the temperature differences during their descent. The measured depth at the bottom was measured with a manometer at 10,916 ama plus or minus 5 am. Deep Sea Challenger. On March 26, 2012, Canadian film director James Cameron made a solo manned descent in the DSV Deep Sea Challenger to the bottom of the Challenger Deep. At approximately 05:15 CHST on March 26, the descent began. At 7:52 CHST, Deep Sea Challenger arrived at the bottom. The descent lasted 2 hours and 36 minutes and the recorded depth was 10,898.4 meters when Deep Sea Challenger touched down. Cameron planned to spend about 6 hours near the ocean floor exploring but, due to a hydraulic fluid leak in the lines controlling the manipulator arm which obscured the visibility out the only viewing port in the DSV and caused the loss of the submersible starboard thrusters, decided to start the ascent to the surface after 2 hours and 34 minutes exploring the ocean floor. At around 12:00 CHST, the Deep Sea Challenge website says the sub resurfaced after a 90-minute ascent, although Paul Allen's tweets indicate the ascent took only about 67 minutes. During a post-dive press conference Cameron said, "I landed on a very soft, almost gelatinous flat plane. Once I got my bearings, I drove across it for quite a distance. And finally worked my way up the slope." The whole time, Cameron said, he didn't see any fish, or any living creatures more than an inch long. The only free swimmers I saw were small amphipods shrimp-like bottom feeders. Planned manned descents. Several other manned expeditions are planned. These include, Triton Submarines, a Florida-based company that designs and manufactures private submarines, whose vehicle, Triton 36000/3, will carry a crew of 3 to the seabed in 120 minutes. Virgin Oceanic, sponsored by Richard Branson's Virgin Group, is developing a submersible designed by Graham Hawkes, Deep Flight Challenger, with which the solo pilot will take 140 minutes to reach the seabed. Dua Marine, a San Francisco Bay Area-based marine technology company established in 1992, that is developing a vehicle, Deep Search, with some support from Google's Eric Schmidt with which a crew of 2 or 3 will take 90 minutes to reach the seabed, as the program Deep Search. Unmanned Descents, Keika. On March 24, 1995, the Japanese robotic deep-sea probe Keika broke the depth record for unmanned probes when it reached close to the surveyed bottom of the Challenger Deep. Created by the Japan Marine Science and Technology Center, it was one of the few unmanned deep-sea probes in operation that could dive deeper than 6,000 meters. The manometer measured depth of 10,911 AMA plus or minus 3 AM at 11 degree 22.39 euro squared N 142 degree 35.54 euro squared E for the Challenger Deep is believed to be the most accurate measurement taken yet. Keika also collected sediment cores containing marine organisms from the bottom of the deep. Keika made many unmanned descents to the Mariana Trench during 3 expeditions in 1995, 1996 and 1998. The greatest depth measured by Keika in 1996 was 10,898 AM at 11 degree 22.10 euro squared N 142 degree 25.85 euro squared E and in 1998 10,907 AM at 11 degree 22.95 euro squared N 142 degree 12.42 euro squared E. Nereus. On May 31, 2009 the United States sent the Nereus hybrid remotely operated vehicle to the Challenger Deep. Nereus thus became the first vehicle to reach the Mariana Trench since 1998 and the deepest diving vehicle currently in operation. Project manager and developer Andy Bowen heralded the achievement as the start of a new era in ocean exploration. Nereus, unlike Keika, did not need to be powered or controlled by a cable connected to a ship on the ocean's surface. Nereus spent over 10 hours at the bottom of the Challenger Deep and measured a depth of 10,902 AM at 11 degree 22.1 euro squared N 142 degree 35.4 euro squared E, while sending live video and data back to its mothership RV Kilo Mona at the surface and collecting geological and biological samples from the Challenger Deep bottom with its manipulator arm for further scientific analysis. The Nereus was operated by the Woods Hole Oceanographic Institution. It was lost on May 10, 2014. Lifeforms. The summary report of the HMS Challenger expedition lists radial area from the 2 dredged samples taken when the Challenger Deep was first discovered. These were reported in the report on radial area written by Ernst Haeckel. On their 1960 descent, the crew of the Trieste noted that the floor consisted of diatomaceous ooze and reported observing some type of flatfish lying on the seabed. And as we were settling this final fathom, I saw a wonderful thing. Lying on the bottom just beneath us was some type of flatfish, resembling a sole, about 1 foot long and 6 inches across. Even as I saw him, his 2 round eyes on top of his head spied a monster of steel invading his silent realm. Eyes? Why should he have eyes? Merely to see phosphorescence? The floodlight that bathed him was the first real light ever to enter this Hadal realm. Here, in an instant, was the answer that biologists had asked for the decades. Could life exist in the greatest depths of the ocean? It could. And not only that, here apparently, was a true, bony teleost fish, not a primitive ray or elasmobranch. Yes, a highly evolved vertebrate, in time's arrow very close to man himself. Slowly, extremely slowly, this flatfish swam away. Moving along the bottom, partly in the ooze and partly in the water, he disappeared into his night. Slowly too, or perhaps everything as slow at the bottom of the sea. Walsh and I shook hands. Many marine biologists are now skeptical of this supposed sighting, and it is suggested that the creature may instead have been a sea cucumber. The video camera on board the Kaiko probe spotted a sea cucumber, a scale worm and a shrimp at the bottom. At the bottom of the Challenger Deep, the Nereus probe spotted one polychaete worm about 1 inch long. An analysis of the sediment samples collected by Kaiko found large numbers of simple organisms at 10,900 am. While similar life forms have been known to exist in shallower ocean trenches and on the abyssal plain, the life forms discovered in the Challenger Deep possibly represent taxa distinct from those in shallower ecosystems. Most of the organisms collected were simple, soft-shelled foraminifera, with 4 of the others representing species of the complex, multi-chambered general Leptohorlosis and Rheophax. 85% of the specimens were organic, soft-shelled allogramiids, which is unusual compared to samples of sediment-dwelling organisms from other deep-sea environments, where the percentage of organic-walled foraminifera ranges from 5% to 20%. As small organisms with hard, calcareous shells have trouble growing at extreme depths because of the high solubility of calcium carbonate in the pressurized water, scientists theorize that the preponderance of soft-shelled organisms in the Challenger Deep may have resulted from the typical biosphere present when the Challenger Deep was shallower than it is now. Over the course of 6 to 9 million years, as the Challenger Deep grew to its present depth, many of the species present in the sediment died out or were unable to adapt to the increasing water pressure and changing environment. The species that survived the change in depth were the ancestors of the Challenger Deep's current denizens. On March 17, 2013, researchers reported data that suggested microbial life forms thrive in the Mariana Trench, the deepest spot on the Earth. Other researchers reported related studies that microbes thrive inside rocks up to 1,900 feet below the seafloor under 8,500 feet of ocean off the coast of the northwestern United States. According to one of the researchers, you can find microbes everywhere. They're extremely adaptable to conditions, and survive wherever they are. See also, Sirena Deep, Galathea Depth, Notes. External links. Official press release regarding Challenger Deep operation. Mariana Trench.